Well, as we saw before, science is a Christian way of determining the truth in detail about the Creator's creation. And Francis Bacon put forward this scientific method specifically because we tend to think we know better. And he put forward the reason for putting forward the scientific method: nature carries the stamp of the Creator, whereas man's reason carries the stamp of his own folly. We will have it that all things are as we in our folly think they should be. And because of this, he put forward the scientific method, which shows us the only way to search for knowledge about God's creation is to take observations and measurements, and that is where we should start, looking at the way things actually happen in God's creation. And the people who were prepared to do this were the Christians who realized we have a Creator, one Creator who doesn't work against himself. He lays down laws and he expects them to be followed. He speaks the truth. He is reasonable. We have every reason for believing that his creation will be guided by laws which we can seek, and in seeking those laws and finding them, we can get an idea of the Creator himself. And as a biographer of Isaac Newton, one of the greatest scientists, said, were it not for Newton's God, he would never have gone looking for his laws. Now, Isaac Newton, one of the greatest scientists of all time, Leonhard Euler, he said, were it not for Newton's God, you'd not have gone looking for his laws. But the next, I think, great scientist in Newton's line, he carried on Newton's work, Leonhard Euler, he said, in our researches into the phenomena of the visible world, we are subject to weaknesses and inconsistencies so humiliating that a revelation is absolutely necessary to us, and we ought to avail ourselves of it with the most powerful veneration. In doing science, we make such humiliating mistakes that we desperately need God's revelation, the Bible, to keep us on the right track. Because unless we consult God's revelation, we are sure to go astray. Gottfried Leibniz, he said it is a privilege for us to do science, because it allows us to see into his mind. It is especially in sciences that we see the wonders of God, his power, wisdom, and goodness. That is why, since my youth, I have given myself to the sciences that I loved. Now, you will notice, if you know much about science, that these three scientists I've quoted, they didn't call themselves scientists. The word scientist only came into existence in 1840. They called themselves natural philosophers. And these three people were all professors of mathematics. And the reason for mathematicians being great scientists is, as Robert Fisher pointed out in Science, Man and Society, the language of mathematics, which consists of its symbols and relationships, is very much at the heart of all fields of science. And that's because this language of mathematics deals with numbers and measurements. Science starts with observations and measurements, and by far the best language for using clearly to deal with measurements is mathematics. As Albert Einstein pointed out, science demands the highest possible standard of rigorous precision in the description of relations, such as only the use of mathematical language can give. Now, Einstein was a very great scientist. He got a Nobel Prize for his work in Brownian motion. He could have got it for his work in the photoelectric effect. He's best known for relativity because it suits the scientific establishment to blow up relativity. But that wasn't his great forte in science. He was a scientist in many fields, and he points out that only mathematics can adequately deal precisely with what scientists are dealing with. Now, it used to be a very well-known saying in science. I don't know that it's so often stated nowadays, but it used to be pointed out, mathematics is the most powerful tool in the scientist's toolbox. Now, we've already looked at a professor of physics who has noticed problems in what science is doing, and Sir Herbert Dingle, like all scientists, has to be very proficient in mathematics, and he pointed out, in the language of mathematics, one can tell lies as well as truth. And it can be very difficult to tell one from the other. And he made this statement in his famous book, Science at the Crossroads, which I've mentioned before, in which he was pointing out there are problems in science, it's going the wrong way, and we need to take the right direction, which science in general simply ignored. And he pointed out that scientists have relapsed into imagining how nature ought to behave and then assuming that she does so. Well, if you remember Francis Bacon's reasons for bringing in science, is that we will have it as all things as if they behaved as we think they should. And here, Dingle is pointing out that scientists are going back to that way of behaving. The factor which has made this possible is the exchange of reason for mathematics. Mathematics has become the master in science instead of the servant. Instead of it being the most powerful tool in the scientist's toolbox, it is now the be-all and end-all, and it rules the way scientists think instead of reason. Now, mathematicians began rebelling against working to describe they rebelled against mathematics working to describe and analyze the Creator's creation at about the same time as the secular scientists started bringing in the scientific establishment. And secular humanist mathematicians demanded to be autonomous. Mathematics had been the tool to describe accurately the creation. But they didn't want to describe the creation. They wanted mathematics to be their own creation. They wanted to rely on it as a construction of their own mind, completely devoid of the creation, completely divorced from it. And in this search for getting away from the creation, Leopold Kronecker was one of the first people to look into this, and he saw that if you're dealing with the science of numbers, you have to start with numbers. That's the only way. And numbers come before mathematics. In almost any culture, anywhere in the world, even if they don't have a word even to describe mathematics. Everybody, from the age of about 2 or 3, starts to count 1, 2, 3, 4, 5. That is the basis of mathematics. And Kronecker pointed out, God made the integers, these counting numbers, but all else is the work of man. Now, Georg Cantor then responded, Kronecker needs God, I do not. And he put forth a basis for mathematics based on infinity. Infinity is not part of reality. It is a mathematical extraction of a limit. The limits beyond which you just can't count anymore because it's just too big. It's not a part of the creation. And he built a mathematics based on this concept of infinity, and he said, right, well, he needs God, I don't. I've built a mathematics which is not based on anything real in the creation at all. And all the mathematicians were absolutely delighted. They said, oh, wonderful. We are no longer confined to this creation. Infinity is a creation of the mathematician's mind. It's all ours. But it didn't take all that long before a mathematician called Kurt Gödel put forward a theorem called the incompleteness theorem. Now that's a theorem, simply in a nutshell, says that in a mathematical system, any mathematical system which is powerful enough to actually do any mathematics, there are true propositions which cannot be proved to be true. There are false propositions which cannot be proved to be false by the mathematical system itself. Now that may sound complex, but we can look at a very simple example from the normal mathematics we know, and you can use mathematics to solve problems. If we want to make a square sandpit with an area of 9 square meters, how big should it be? Now, if we let the length of the sides be L, then the length of this sandpit is L, and the breadth is the sandpit is L, and we know the area is the length times the breadth, which is now L squared. If L squared is 9 square meters, then L is the square root of 9, 3 or minus 3. Now, this is dealing with mathematics of the real world. So we look at that answer and say, oh, we don't have minus 3 on a tape measure. The smallest measure that a tape measure goes down to is 0. There is no length which is smaller than 0. So we can see this minus 3. It is a result that comes from our mathematics, but it doesn't apply to the real world. So our knowledge of the real world tells us that the 3 can be true, but the minus 3 can't. And if you make your sandpit 3 meters by 3 meters, you find the area is 9 square meters, it gives the right answer. How do we know that either of these answers are right? How do we know they're not both wrong? Well, because of our knowledge of the real world. If we are dealing with mathematics which is based on mathematical abstractions, how do we know if any of the answers are true? Or if all its answers are true? Or if some of them are true, which ones are true? We don't know. And the mathematicians were they were unnerved a bit by this, and they said, well, yes, it's true. But David Hilbert spoke for them all when he said, no one shall expel us from the paradise which Cantor created for us. This complete independence of the Creator and his creation was a paradise which they were not going to be thrown out of. So they would search for the way around this, and just as he retired, I think it was in his retirement speech, he said, we must know, we shall know. We shall be as gods, knowing good and evil, knowing the truth from the falsehood, knowing right from wrong. We will get there. Now, among all these mathematicians seeking to be free from the Creator and autonomous, there were a few who said, well, this is a futile quest. Why should we want to be free from the Creator? Now, one of these was a man called Charles Dodgson. He was an Oxford Don. He taught mathematics there for, I think, pretty well the whole of his professional life. And he was a Christian, and he looked at this and he said, this is utter nonsense. And Charles Dodgson was better known as Lewis Carroll because although most of his life's work with mathematics, 2 atoms of his life's work became very well known. Alice in Wonderland and Alice Through the Looking Glass. Now, children loved his Alice in Wonderland. But Alice Through the Looking Glass is a parody. It is an ironic look at mathematics and a warning to children about the foolish authority of grown-ups. And in Alice Through the Looking Glass, everything is back to front. Everything is the wrong way round. And this is his comment on the new mathematics. And he has 2 mathematicians in his cast of characters. Now, one is the White Queen, who is the absent-minded professor type, and the Red Queen is the overbearing, domineering, know-all type. And so he has Alice encountering these mathematicians as, the child that the Bible says you have to be to enter the kingdom of heaven, looking at things with childlike simplicity. And the White Queen says something totally incredible, just like lots of the things that the new mathematicians say, totally incredible. And she says, but one can't believe impossible things. And the White Queen says, I dare say you haven't had much practice. Why, sometimes I've believed as many as 6 impossible things before breakfast. And I can assure you, if you're going to go into the new mathematics, you will have to get pretty accustomed to believing impossible things. And then she talks with the Red Queen, who glibly talks about a hill being a valley. And Alice says, but a hill can't be a valley, you know. That would be nonsense. Well, it's not nonsense to a mathematician. In their mathematics, they can do a transformation to make into a hill, into a valley, very simply. And so the Red Queen says, you may call it nonsense if you like, but I've heard nonsense compared with which that would be as sensible as a dictionary. Now, I'd like to give you an example. Einstein, in Relativity of the Special and General Theories, made a statement, there is no more commonplace statement that the world we live in is a four-dimensional space-time continuum. Well, that may be familiar to you. It's an everyday assertion of mathematicians these days. Well, just a minute. As far as I know, we live in a three-dimensional continuum. There's length, we know what that is. There's breadth, we know what that is. There's height, we know what that is. That's the world we live in. What about this fourth dimension? Well, the four dimensions of this continuum are length, yes, we know that. Breadth, we know that. Height, we know that. And imaginary time multiplied by the speed of light. Oh, yes. Imaginary time multiplied by the speed of light. I'm sure we're all familiar with that. We know exactly what it is. Well, I don't. But the mathematicians, yes. Minkowski, a mathematician who followed Cantor in using a mathematical abstraction for the basis of his mathematics. He dreamed up this scheme, and Einstein realized it would fit in very well with his relativity. And so he said, well, everybody knows. We actually live in this four-dimensional continuum of imaginary time multiplied by the speed of light. Now, there were plenty of scientists who saw this kind of nonsense coming into science, because science uses mathematics, and this kind of nonsense was being brought in, and Frederick Soddy, who was one of the greatest scientists of the last century, he gave an address to the Nobel Prize winners of 1954. And his address was pointing out to the scientists that science is going in the wrong direction and we ought to be careful of it because it is going into the realm of abstract mathematics instead of science. And he said, whilst there is no objection urged against mathematicians doing whatever seems good to them in their own sphere, quite definitely they should be stopped from presenting their whims as science, let alone pretending that in the last analysis they are the real scientists. Now, this is a warning that he's put out, but very few people took notice of this warning, and what has happened is that to a large extent the whims of these mathematicians have become regarded as science. And Professor Brian G. Wallace, who I've mentioned before, he was a professor of physics at the University in Florida. He produced a book, The Farce of Physics, in which he documents how science has gone completely on the wrong track. And he points out the word scientist entered the English language in 1840, and few individuals earned a living doing research. At that time, a handful of American scientists were taking steps to transform their status and image and separate themselves as professionals from those they considered amateurs. The major tactic used to create this artificial separation has been the elaborate use of technical jargon and complex mathematics. Now, this new mathematics is perfect for that. Because how many people outside of science can understand things like imaginary time multiplied by the speed of light? This is perfect for separating scientists away from ordinary people who only know about common sense things. And this erection of higher and higher barriers to the comprehension of scientific affairs is a threat to an essential characteristic of science, its openness to outside examination and appraisal. And because of this, modern theoretical physics has become to a large degree little more than an elaborate farce, and it's more than just theoretical physics, which has followed this route and become little more than an elaborate farce. Well, let's look at some of this elaborate farce. I'm sure we're all familiar with the popular story today that the universe started as a big bang. Now, in the beginning, there was nothing, and somewhere in the midst of this nothing, there was a quantum fluctuation in a wormhole, and out of this wormhole, this nothing, everything exploded. So we have all the material of the universe coming out of this initial wormhole, which is millions of times smaller than an atom, by the way. Nobody's ever seen a cosmic wormhole. It's millions of times smaller than anything could be observed. It is a production of this funny mathematics. You can get these things in funny mathematics so well. In the Big Bang you can have it. That was the origin of the universe. But out of this wormhole, all this material, these hundreds of thousands of millions of tons, they're coming out as hydrogen. The hydrogen gets together, it bumps into each other, and it forms stars. In the stars there are nuclear reactions which form all the other elements. These elements explode and scattered throughout the universe, and they can come together to form the Earth, and that's how everything happened. Well, it may be a silly story, but at least you can understand what they're saying happened. The trouble is, the observations don't agree with that. So they use this imaginary time multiplied by the speed of light, and the mathematics dependent on it, to explain all this. And if you want now to see actually what the mathematics says and what the scientists these days actually believe about the Big Bang, it doesn't correspond all that well with what you've been told it is. You've been told it's something like I described it, but if you go to NASA's website, they have a course in Big Bang cosmology. It's called WMAP's Universe, Cosmology, the Study of the Universe. You could go on the internet and have a look at this, and on its first page, we'll find that region of space that is within our present horizon was indeed no bigger than a point in the past. That's this point. This is millions of times smaller than an atom, and everything exploded from it. Nevertheless, if all of space, both inside and outside our horizon, is infinite now, it was born infinite. Hey, wait a minute. If it was smaller, millions of times smaller than an atom, how can it be infinite as well? If it is closed and finite, then it was born with zero volume. Well, that's what they told us, and grew from that. Well, that sounds as if they're now saying, okay, right, there was this original nothing, and now it's grown from that. In neither case is there a center of expansion, a point from which the universe is expanding away from. Hey, wait a minute. What does this mean? It started off from nothing and it expanded from that, but there is no point from which everything's expanding. Well, if that reminds you of, you may call it nonsense if you like, but I've heard nonsense compared with which that would be as sensible as a dictionary. Well, let's carry on and look at the next thing that it tells us. The Big Bang did not occur at a single point in space as an explosion. But just a minute, that's exactly what you told us did happen. It is better thought of the simultaneous appearance of space everywhere in the universe. Now, first of all, they tell us one impossible thing, then they tell us another impossible thing, which was, what are we supposed to do? Well, we're obviously supposed to practice believing impossible things like the White Queen, believing 6 impossible things before breakfast. Now, this is absolute nonsense. Where did science get lost? It's completely lost now. There may be people who believe that, but they have to be scientists to do so. I don't think any normal person, I don't think anybody in this room would believe this nonsense. How did scientists come to believe all this? Now, I think the problem is they didn't heed Euler. In our researches into the phenomena of the visible world, we are subject to weaknesses and inconsistencies so humiliating that a revelation was absolutely necessary to us, and we ought to avail ourselves of it with the most powerful veneration. We go astray in science. The only way we can keep on the right track and stop going into utterly humiliating rubbish like this, we must consult the Bible and see if our theories could be true. We need to be like the Bereans, who, when they heard something, they consulted the scriptures to see if it could be true. As Leibniz pointed out, it is especially in sciences that we can see the wonders of God, his power, wisdom, and goodness. That's why, since my youth, I have given myself over to the sciences. Because the sciences is a search into the truth of the creation that the Creator made. And if you get to the stage of saying, Kronecker needs God, I do not, then you are on the road to complete nonsense. If you look in Thessalonians, 2 Thessalonians, it says, because they did not retain the truth in their understanding, God hands them over to delusion that they would believe the lie. And that is exactly what has happened. Where did science get lost? It got lost on exactly the same path that the mathematicians got lost on. The desire to be autonomous, to deny the Creator, and to be their own God, deciding what is true, what's right, what's wrong, and they've gone into utter and complete nonsense. Well, are there any questions? Yes. Well, I don't know if anyone here is old enough to remember when the new maths came in. And the new maths is based on set theory. And all the parents of the school children said, but what's all this? The maths we did at school, it was based on things you can understand, and it was useful stuff. It enabled you to work out which electricity tariff you could choose to get the cheapest bill at the end of the month. It was all about solving problems that we actually deal with. Well, what is all this set theory to do with? What problems does it solve in reality? And there was a real discussion because the parents of the children would look at this stuff and say, but what use is it? And that faded away as people accepted this new wisdom. And if you wonder why nowadays our children seem to have so little ability to solve problems mathematically, well, I think this is probably where it lies. Fortunately, homeschoolers can still teach, be taught the world as the Creator created it, and the mathematics which is relevant to the Creator we created it. But there certainly was a big uproar when the new mathematics was brought into the education system, and people said, but this isn't useful like the mathematics we were taught. Yes. Well, look, the new mathematics has to be able to deal with the reality. If you base a mathematical system on reality, it will give you answers about reality. But the new mathematics was introduced to show that you can build mathematics on a mathematical concept. In this case, sets. Now, the mathematics that's taught in school is not all totally useless, because you can put as much of the real world into it as you want, but you can put as much of the imaginary mathematical world into it as you want. In Minkowski's mathematics, you've still got length, breadth, and width. They are the reality. But your mathematics includes the dreams of the mathematician of imaginary time and multiplied by the speed of light. So you can still get useful results from a new mathematics system which has enough of reality in it. But you can build a mathematical system purely based on mathematical concepts which are totally removed from the wisdom of this world. The mathematician is now in a position to choose. He can choose whether he's going to deal with a mathematics that deals with this world or one that deals with his imagination, and he can mix and match as he likes. And the problem is, when he takes reality as we know now, the universe, And he mixes and matches in things from his imaginary system and believes that the results he gets from the imaginary part of his analysis is as valid as what he gets from the real part of it. That's the problem. It's mixing and matching. Now, there is a very famous astronomer, I think he's probably retired now from Cape Town University. He had the highest science rating in the country. And he worked with Stephen Hawking on one of Hawking's books about the universe. And in this, it's using the mathematics that Hawkins uses. But he pointed out that he can do the same thing and produce a universe where the Earth is the center, and you cannot disprove it by any observations. So the mathematics you can use, if you want to bring in the basis, just the real world, you can get from that same kind of analysis a universe where the Earth is the center. It's completely different to the one that Hawkins got, and he got with working with Hawkins on their assumptions, where there is no center. The edge is everywhere, but the center is nowhere. Now, this is a ludicrous universe. It doesn't correspond with any object that anybody has ever seen. Has anybody ever seen an object which doesn't have a center? Has anyone ever seen an object which has its edge everywhere? But it was pointed out, well, all you have to do is make some changes and you can get a real universe. It does have a center. The trouble is, that center, all the observations show, is the center of the universe. And they don't like that, because they want the Earth to be nothing at all important, because otherwise you get a universe which agrees with what the Bible says, and we can't have that. So Hawkins' book, the one that Hawkins did with this South African scientist, it's all built on this mathematical wonderland. No mention of the possibility of a universe with the center, because that center has to be the Earth. It's all a matter of choice. Do you want to live in the universe God created, or do you want to live in the autonomous universe of the mathematicians and the scientists who can create a reality of their own? But you can still do really worthwhile things with mathematics. Dodwell refused to go in this direction. He stuck with the real world, and he produced very useful mathematics, things like matrices and determinants and solutions of simultaneous equations and statistics. For example, dealing with the way elections work. So his mathematics was all based on the reality. And if you look at a commentary on mathematics nowadays, they'll say, oh, well, all Dodwell's work was elementary mathematics. In other words, it's the mathematics of the real world. So they look down on that, but there are still mathematicians who deal with the real world, and all mathematicians at times have to deal with the real world. But they now have the privilege of being able to deal in any world they want.